All right, good. Okay. So here we are. We're just ready to kind of finish. We're actually close to finish on this one, really. So I just need to, now that I've kind of know the locating dimensions for that particular feature, the whole, let's do the controls on the size now. So what I want to do is I think it's really common. What I don't like about the old drawing, if I pull that up real quick, a couple things I don't like is I think it's generally pretty common to have a tolerance on a hole. So this one has no tolerance, other than I think we could still apply the tolerance that's here to even this dimension. I think I'm just going to display that. To me, I like that visual like plus or minus dimensioning there on the hole size. Um, and the reason why is because that plus and minus dimensioning will be impacted by the actual tolerance, which is what's in here, the actual positional tolerance. This is true position geometric symbol, right? You're gonna get quizzed on that on all kind of quizzes in ADDA. You're gonna have to identify symbols for sure. That's it. That's a true position. It looks like a crosshair. So it's the true position tolerance for a diameter of 0.025 at maximum material condition to datum A, B, and C. So pretty much I like everything about this. This is definitely, instead of being the rectangular coordinates, we're actually going to say, hey, make our tolerance zone round. That's what the diameter sign is here. So it's a true position with a round tolerance zone of actually 0.025, which is even larger than the tolerance zone that I kind of displayed there. So it's actually technically this has got a little more tolerance than even just the standard tolerance. And then it's at maximum material condition, which just means this feature is a hole. So maximum material condition means that there's more material in the hole, the part is heavier. And so I think of the most material in the hole, that's maximum material condition. So if there isn't a symbol here, that means it's regardless of feature size. And so it's just inferred. I mean, generally we apply two different symbols. Like there's an L for least material condition, which on a hole would be the largest hole. And then we have maximum material condition, which on a hole is the smallest hole. And then if we don't have anything, or sometimes there's a circle S. A circle S was the old way they established regardless of feature size. Now they just drop that symbol, but you can still see it. I've never seen it, but you can still see it, I guess, show up. Otherwise, regardless of feature size means I can't really consider uh, a maximum material condition and a least material condition, which means I really can't get bonus tolerance. If I don't use like a condition modifier, then I don't get like bonus tolerance added because as my actual feature size departs from its theoretical correct size, I actually can kind of gain tolerance, right? And we can go back to our sketch and kind of like play around with that concept and what that looks like. I will go back and kind of go back to that sketch that I was doing, but let me just at least build this first, and we'll explore what the heck this even means. But what I don't love about it is because sometimes with the maximum material condition, I get bonus tolerance. I kind of like to see the tolerance right next to my dimension. Maybe it makes it quicker for me. I don't have to be like, oh yeah, that one's not tolerant, so my tolerance is 5 thousandths. Okay, then I do 5 thousandths plus. If I've got bonus tolerance, then I can kind of increase. We'll see how this works. Let me see. I'll have a hard time explaining it for sure, but let's jump in and see if I can fumble this. Okay. So essentially, it means that this size dimension for this feature, we haven't moved from these holes yet. We're still here. We're going to beat him to death. I'm going to add some tolerance to this. I'm just going to add I'm just going to add it as a symmetrical tolerance to this 5 thousandths so that I can just kind of see it clearly. So this dimension here, I'm going to say, really, I want to see a symmetric tolerance that is 5 thousandths, which is just not me. It's me kind of just using the tolerance block. It's because I wasn't given one that's outside of that. So I'm going to say, hey, this is my hole size is 0.563 plus or minus 5 thousandths. And then I'm going to add the geometric feature control frame, which is another symbol library box here, kind of where your welding symbols are. It looks like, oh, it's right next to your datum. This one right here. And this thing can do all kinds of things. It can form its own leader line to call out a surface control of sorts, a form control. But I think if I hover on my over here, I'm going to apply it to this. I think if I just click it here, it's like I've selected. Yeah, yeah. Once I think this may be goofy to work with, just like the datum feature symbols are kind of goofy to work with. You may have to play with that a few times. I can just say okay and get back in to modify it, but I'll try to mess this up a few times here and see if I can get it to jump around. Kind of weird. It's just your feature control frame box. Maybe if I just select the dimension. See, sometimes it has a leader, but and so that's goofy. I wouldn't want it to be like that. So you just got to get kind of good at, I think it's like you pick it. Maybe if you pick this first and then do feature control frame, that's what turns it blue. And I feel like now if I just double click, it will hook to the dimension. So I guess maybe that's my preferred way to place this. And CAD's a little bit different than this one. So it's like, so I like to select my dimension. Then I'm going to say I'm going to add this feature control frame that goes blue. And then I'm just going to double click and it'll kind of snap to it. And then I'll just say okay real quick. But then as I move my dimension, I would hope that this thing like moves with me. Like if I go to move this leader line. Oh, it doesn't, but it will if I snap it right. Let me see. Maybe I have to actually snap it too. Oh, let's see. Let's play around with it a little bit more. I just want to get it till it snaps to it. And there is a way. Select my dimension, take my...
But I don't know how.
Exactly right. I feel like there's a grip that shows up.
Well, that's like the extension line of the dimension.
Click the extension line. It wants to do a leader.
Go down just a little bit.
And you have a, it's like you'll almost have like a midpoint of your dimension. So there's right there's one. That would be above it. I want it to be below it. Oh, I did miss it. You guys are all watching. It's just like this is funny. Yeah, dude, this is what can kind of be annoying.
Go further down, yeah. Yep.
Ah! You guys are excellent. Love it. Because now that when I move this thing, this is what I want. Yeah, I want that thing to jump with it. So this is definitely how I want that to be. What a pain that is. They you would have thought they would have made that a little more intuitive, but you know, Inventor helps us in some ways and confuses the crap out of us in others. That's one of them.
Who made this program? Hey.
Yeah, and even go to move that little datum, and you have about 5 control points to make it all zigzaggy if you want. So, which can be helpful, but I think I try to keep it simple. So I'm going to go back in here and modify this. I'll just go to no preset here. So yeah, you've got so we can build multiple rows of this. I want to keep this really simple. A single row control on this for me. So it's going to be positional. So I have all these, you know, here's you got to be able to know what these are to be able to use them. That's why I at least like that's what we mostly quiz you on is identifying these. True position looks like the target, kind of like a crosshair. And then I can add, here's a little symbol library, I think, to insert just some standard symbols and diameter and degree here, plus or minus. I want the diameter sign because my tolerance zone is rounded shape. The whole concept of moving from rectangular tolerance zones in this situation would be I want a round tolerance zone. It increases it at least minimally increases my tolerance zone by 54%. So this makes a huge difference. And I'll just use what they say. They say it's 0.025, 25 thousandths tolerance zone. Yeah. And then I'm gonna apply a condition modifier. So if I don't put one, that means that I can't really consider the feature size and gain bonus tolerance. If I put one, then I can. I can actually measure actual size and gain bonus tolerance. So I'm going to put a material, and so I think you see most common maximum material condition. And the reason why is because once we get in here and do some of this, or you get a little more familiar, you will gain the most bonus tolerance if maximum if we kind of tolerance to maximum material condition. Because once we deviate from maximum material condition, we can kind of once we deviate size wise, I'm thinking of this size. Once we deviate from the the maximum material condition of this size, we will gain however much we deviate away from it dimensionally, we can add that to our tolerance. That's why we say we pick up a bonus tolerance. So, okay. And that's why I think it's the most common. You'll see the reason for it is because you gain even sloppier work in some ways. But the symbol I think is located right here. Maximum material condition. Here's least material condition. And here was that regardless of feature size, which is generally omitted these days, but it still exists here. But maximum material condition is my modifier. And then I think I can add a more complex type of tolerance here, or I can go right to my datums. And so I'm going to control this from datum A because that's got some locating dimensions for this particular feature of size, right? Datum A makes sense to this because it's that bottom surface datum that I'm pulling dimensions to this from. So that would make sense. It's kind of in its relationship to datum A. And then I think, so I kind of think of that like this tolerance, this geometric control, datum A impacts that control, and datum B does too, at least as far as its axis of symmetry through the part, which I'm not explicitly controlling any more than just generally implying that I still need it to be perpendicular to datum B, which is the front surface that I'm really drilling into. And so adding B here, while there's no necessarily dimensions associated with it, by putting it here, I'm applying that I am still perpendicular to that datum as I bore this hole through. And if I need real control over that, I can establish some form control over how cylindrical or how parallel or how straight. Yeah, I could put in some form control of that if I needed to. And maybe the thicker the part, the more I have to worry about form control through, because oh man, you know what? I've kind of caught blurbs of down in Utah, the LDS temple, Salt Lake Temple, built way back when. And the engineering they put into it is a marvel in itself, and it's amazing. But they've actually bored holes through from the freaking from the upper structure all the way down through to its foundation and into like a better, like actually a movable foundation. And I can't remember how accurate they were when they bored those holes through. But can you imagine the amount of deviation you could have drilling through a building from especially like a multi-story building like that, and try to exit the hole where you think you're gonna. I mean, it's just amazing. That's the coolest thing about what they've done there is it's just modern engineering, trying to hold an old building together that's gonna fall apart otherwise. I think it was just originally stacked with some huge, humongous Mongoloid rocks, and the problem with that is they'll still fall off each other and crush you and kill you. So I think they bound them together so they couldn't fall. Is why they bored those holes through. It was actually almost just like put a turnbuckle between the roof and the foundation to hold the flipping building together. Amazing. So I would love to have been a part of that. Interesting. Or any kind of building they're preserving like that. Pretty cool. It's just all over our news right now, I think. That's why I looked into it again. I've seen some little blurbs on some of the machining or drilling, core drilling. Okay. So, and then C is going to be, I'm going to add dimension datum C to this because um, my locating dimensions come from left and those are directly pulled from datum C. So really all three datums affect the position of this four-hole pattern here. And so this is what the GD&T symbol would be to control that. And so
That gives it like a spherical area of tolerance because it's 3 dimensions that it.
kind of in some ways, I guess, I still think of it as just like top-down view, I guess. So that's an interesting thought, and I think some of you with more critical thinking skills will be better than me at interpreting some of this. But I'm going to go back to my sketch and just think about it for a minute because what I've got is a 0.025 tolerance zone is what it's telling me, and that's a diameter. So let me go back and see what that looks like. Back on this little old sketch that I had here, where I was kind of exploring the original tolerances from the tolerance block. I'm going to edit the sketch again, and that's what that circle was just I wasn't making it any bigger than what, the original tolerance block. And so this isn't really necessarily the size of my true tolerance because in this case, for whatever engineering standard had been developed, they were like, actually, those holes can be tolerance to a point 0.025 thousandths. Will be sufficient to actually make the fasteners or hardware or the relationship of how this bolts to something else potentially will fit up still. So they actually even gave us more tolerance than just the applied one from the. So I'm going to delete this. They gave us more tolerance. So they actually have, here's my original rectangular tolerance. If I was only using the tolerance block, that's the only space that my center point of my hole could live in. But in reality, because I'm using true position and a diameter, this thing is actually 0.25. Oh wait, 0.025. Let's make sure I've got the right dimension. 0.25 is a little bit too big. That would be really sloppy. Let's say 0.25, 25 thousandths. Still, this is my kind of mock circle here. I'm going to constrain this to this. And now so this is what that geometric symbol means to me is as long as my center of my circle lies inside that little 0.25 diameter tolerance zone that's round in shape, this is how much my whole location can kind of vary. You can kind of see it like arc around here. It just I mean, this has even increased how kind of sloppy I can be with the position or the initial drill point of this hole can vary a lot. And even with, I mean, yeah, I think a good general, like, it's nice to know, like, well, how do I know where even like a baseline to even start tolerancing would be, right? I mean, your tolerance block kind of gives you that. You see that at 3 decimal places, that's 5 thousandths of tolerance. That's a pretty high level of control. Anything like 1 or 2 thousandths, you're expressing like extreme control, like really fine control. I think a machinist might say like a general tolerance to them. And I was watching some videos. They say maybe 14 thousandths is kind of their medium general tolerance. So really our tolerance zone is 25,000. So it's really quite, a coarse tolerance zone. Yeah. And you can leave them on your computer if you want to use them. Yeah, yeah. Go ahead and leave them there, David. Yeah. So, and that's why when I went, it was just me watching some videos, is why I said I don't like these like surface control tolerances. For one, they're quite a bit different from each other. And the other is maybe this is too fine of a control. Maybe 10 thousandths or 14 thousandths would be more realistic for just a general purpose part. Or maybe no control if it was just understood with a surface finish that it should be, if they surface finish it to some description, which we don't have any surface finishes here, but some of our GD&T stuff does. Okay, okay. So that is what this thing is saying is this thing can live uh anywhere in here, which I mean this drastically increases your tolerance zone for this particular hole. So this is a way sloppier tolerance, but it's designed around the functionality of the part or the interchangeability of the part. And so as long as my hole is like the center point lives in somewhere here, it's way easier to hit that point than this little coordinate tolerance zone. So that's my big study of that. And if that makes sense to you, great. If it doesn't, you need to study a little more. That's great too. Like a little more reading. Watch the video that I posted to the resources for this week. It's what I'm really going over here. So as far as I'm concerned, I like these. I know I need to do a little like dimension. I need to like clean these up a little bit before I'm done, but I'm going to move on from those. I feel like I have geometrically, I'm controlling the position of those with GD&T. I've got basic dimensions off my datums to control location. I can move on. That's one feature of size GD&T located on my drawing. So let's do the other hole that way. And it's about the same concept here. Um, so my hole here, I'm locating. Okay, great. This is off datum A. Oh, great. This is going to be a basic dimension then, because I'm locating from a datum. So I'll go ahead and get it away from having to apply this tolerance block, box it around, protect it, fence it in. It's a theoretically perfect dimension. And then the other one is going to be this 2.5, 2.25 here. So that's the other. I'm going to call this basic off the datum because it's off of datum C. If I had pulled that dimension from over here, you notice none of these dimensions pull from this side because it's not a datum. So I really shouldn't have any dimensions coming from right to left. However, I could have made this C's datum and pulled that way. I would just have to make sure my dimensions and my datums are communicating correctly. I don't have something that is contradictory. Okay. So now it's just a single hole. I'm going to simplify the GD&T for it though. This is kind of what it's saying here, the original document that I've posted up. I'm going to also include oh, I did want to go back before we jump on because let me just go back to those features of size and talk about kind of bonus tolerance here. So what I've said here now is that here's kind of my actual size, my theoretical exact size. It can be plus or minus this. Here's my maximum material condition holding modifier for my tolerance here for my actual location tolerance. So let's kind of infer how these two work together because this is what you have to do next week is try to make sense out of like, well, how much tolerance, what they'll say on a quiz question will say, okay, so let's say I give you a dimension here um, at the max size. So this means it can go up 5 thousandths plus or minus 5 thousandths. So I'm going to pull out my little calculator here and I'm going to say, it'll be like, okay, it'll say if you can read and understand the GDT symbol here, tell me what the tolerance would be if the part was at its max size, which would be, oh, okay, that's 0.563 plus those 5 thousandths. So that's max part size. That's max hole size, which really that would be like least material condition because it's a hole, right? You'd have to identify that that's a hole. So when I go up to this, when I go up to the top side of when I apply this dimensional tolerance, my hole can actually be this large, right? Which is the least material condition. That's really confusing. I should have started with the other way. Back up. Well, maybe this works. I don't know. Does it work? Roll with it. It's just that what I'm saying is that would be least material condition, right? And so if my part size is this big, um, how much positional tolerance am I allowed here? So this would say at maximum material condition, you're allowed 0.25. As you deviate from maximum material condition, um, that tolerance changes. And I've deviated from maximum material condition because I'm at the least material condition. So I've deviated from maximum material condition by 10 thousandths. And so I think I have to decrease my positional tolerance by 10 thousandths. Does that make sense? Or is that really confusing? Let me go the other way and see if it makes more sense. Let me say that what if my part was produced at its smallest size, which is its maximum material? What'll make this make more sense is I'm actually at a size that's not what. Let me see if I can restate this. So let's say I move the other way. Here's my point 563 in my dimension. 563 is my theoretically exact dimension. And if I say what is its maximum material condition? Well, it can be I can subtract the 0.005. Now I'm at its maximum material condition. This is why I think it'll make more sense, which is its smallest diameter. And so once I'm at this maximum material condition, I can now apply this much tolerance. Oh yeah, it's the other way. So I would have said it wrong anyway. Listen to me now. That's why I had to even correct myself. So now here I am at maximum material condition on hole size. I can apply 0.025 thousandths of positional tolerance. So that's essentially what I have when I go back to my sketch and I have that hole size or the little circle that's 0.025 in diameter. That's all the tolerance I have on a part size that's on a feature of size that is at its maximum material condition according to this geometric this GD&T symbol. Now as I depart, that's when I'll start to gain more than just 0.025 in positional tolerance because as I depart from maximum material condition, I can add my departure to my tolerance. So how that works is like, let's say this, I'm going to depart from this dimension and get closer to its theoretical exact size, which is 0.56, yeah, 0.563. So now I've actually departed from maximum material condition sorry, I should just clear that up. 0.563. Yes. So I'm going to say, oh, once this thing was actually bored in there, my actual size. So sometimes we're thinking of actual size too, because now we're kind of like thinking of a scenario where, I'm definitely within tolerance on size because I haven't exceeded least material. I haven't exceeded my limits of my dimension here, because it can be plus or minus 5 thousandths from this dimension. So this is well within the tolerance of the dimension but it's not at maximum material condition because it's actually right in the middle. So I can add the deviation from maximum material condition to the actual positional tolerance. And so this actually even gains me more tolerance zone. So what it does is it says I've deviated from maximum material condition by 5 thousandths. I'm actually 5 thousandths kind of larger diameter hole. And I think I can now add that difference on to my positional tolerance. So I've deviated from maximum material condition, 0.563. Sorry, let me see what I'm going to do. You need to know how much you've deviated it from. So I know that I've deviated it from 5 thousandths. And then I can add that to 0.025. And now I get like a positional tolerance because I've deviated from maximum material condition and I've gained bonus tolerance. So now my actual like tolerance on how big this circle can be is actually 0.03. So if I go back to my little sketch, what I'm saying is if my manufacturer really was able to put in a part at the theoretical exact dimension that I called out, which was 0.563, if they've actually hit that and I had a condition modifier, I gained some bonus tolerance. And now this tolerance zone, I add those 5 thousandths onto this. Not that, wherever my little yeah. Let's see, this one. This is my tolerance zone. It actually becomes a 0.03. So I deviated from maximum material condition. I now have an increased tolerance zone. A bonus tolerance has been applied. You only get that if you're using least material condition modifiers and maximum material condition modifiers. If it's regardless of feature size, I won't get the bonus tolerance that I just added here. So now technically, this is what I have. And if I go to its least material condition, I gain all of the full tolerance. Um, at least the dimensional tolerance. I gain that full like 10 thousandths of diameter here. That is really confusing, maybe. And I don't think I've explained it well, but the kids are going to love it. Back to the Future reference. That might be. Okay. That's confusing. Let's move on. And we'll, I'm going to try to beat this concept to death so that as we start to see quiz questions where they're asking you to interpret it and determine if I've added bonus tolerance or not, we'll work a bunch more of those kind of in class and discuss them and see if we can make sense out of some of them. I think that's quiz for next week though. Okay, so this one here we need to add. We've got its basic dimensions located. We just need to add we've got its size. I'm going to go ahead and adjust its size to include its symmetric deviation just from the title block or my dimension block. It's that is my allowed tolerance plus or minus 5 thousandths. It's right here, plus or minus 5 thousandths for 3 decimal places. So it gets the same. And I'm going to add the GD&T symbol for it for position locating. I'm really going to kind of copy this. Let me see what they've like. I didn't make up these particular tolerances, but it ends up being the same. So really, I'm just going to say I'm going to control it the same way, with the same, exactly the same tolerance zone size even. So I'll just go over here and jump and enter that in here. So feature symbol. Hey, I got it the first time. That one was easier. So really, it'll. I think it will keep your last use if you don't reset it. If you do reset it, it's just going to be the exact same, pretty much the exact same GD&T symbol. I'm going to say okay. And then I just need to do a little cleanup here. Yeah. Anything that's not a basic dimension, then the tolerances apply below. What that would ask my mind is that, well, how does that impact the datum? I'm like, yeah, good question. It would be some studying there. Like, do I need to control overall part size from a datum? Yeah, maybe. And it's not in this part. So all I want to do is like make sure I don't have anything that's kind of weird. Maybe I'll space these off. Yeah.
I think the formal have a particular.
Right here on this one. Yeah, that's true. And so my tolerance would have to do that too, right? I'd have to say there and then increase my tolerance to 4 decimal places as well, which really doesn't change it. It doesn't change the tolerance. But yeah, that's good call. I like that. This one was still 3. Yeah. So 5625. That's great. Good catch. Thank you. And then I just tucked these into their lines. I think I've got that one. Maybe I'll stagger this just a little bit more. I'll keep my surface datums there. I could slide this one up and get it out. Maybe I'll slide it like that. What this one, is there another one? I'm gonna leave them as 3 on the. Yeah. Was there any more on here? Sorry, I'll zoom in. That's it, huh? Yeah, this I'm a little happier with. I know it doesn't exactly look like this, and I dropped some of that stuff. That was my intent here, was to make something just a little simpler, but and maybe slightly a little more accurate, even with my rudimentary GD&T skills. But I'm gonna call this one done. I might, yeah, for you guys finish filling that out. Maybe I gotta update my title here. And I'm gonna jump into the next one. So you guys finish that out. You don't have to make PDFs. You can still just upload the drawing and the IDW and the part file for it. And let's do that. So I'm gonna save mine, and I'm gonna move on to the next. I knew I could only get a couple of them. I think the next one will be a little quicker though, actually. I don't know. It actually is. What's that? I think they're just showing you what I don't know. I'll think about it. Yeah. Yeah. That one's finished. Oh yeah, for sure. I can stop sharing so you can log in. You can. Let me just see something too. While I'm switching over here. Okay, we'll jump over. And I may have gone the wrong way with my, well, we'll revisit that. But really on that same page, 449 in your textbook, because yeah, what Jen was just showing me is there is a formula on the wall chart, GD&T wall chart. It's like a square root of blah blah blah. Um, I can't remember if that was showing the anyway, but your book also shows that if you have an internal feature for positional tolerance, they have a little formula that says actual size. That means the actual part size as was measured and inspected, minus the MMC plus the specified positional tolerance equals the applied positional tolerance. So I may have gone the wrong way, and our tolerance zone maybe has diminished to 0.2 instead of me thinking that it's 0.03. Sorry, 0.02 rather than 0.03. So I'll think about that. I don't want to mislead you, and I know we'll work a bunch more this next week, but even I can get confused on which way.
It's a good thing that like, bolts, like they're already there in position. You're trying to make a flange when on it.
Yeah.
Smaller the